Hey, welcome back, Algebra 1. We're on to week number 2 of this madness and working from home. Woohoo! I'm only a little bit bored. Running out of stuff to do, but hey. Okay, so this week, or last week, sorry, we started talking about systems of equations. We solved them by graphing, we solved inequality systems by graphing, and then on Friday, we saw our first algebraic method of solving systems, and that was by using substitution, where we get one equation equal to one variable, plug it into the other, and then you can solve for both x and y and get your solution that way. Remember, when we're solving a system, we're finding an ordered pair where the x and the y value both work for both equations. In other words, it's a point that's on both of the lines, which means it's where the lines intersect. Or sometimes the lines don't intersect and we call it, and because they're parallel, and we say there's no solution. Or sometimes those lines intersect everywhere because they're the same line, so we call that infinite solutions. All right, today we're going to go through a secondary method to solve systems of equations. I tend to find most people like this way better, but not everybody. So we tried substitution. Now we're going to see elimination. I will, kind of ask you guys to use both on an assessment over this unit. But eventually you'll kind of get to pick which one you like better as we go through other stuff with systems and next year in Algebra 2. Okay, so method number 2 to solve a system of equations is called elimination. And this is where we're going to line the equations up and try to get rid of one of the variables, hence the name elimination, so we can solve for the other. Okay, so your steps are kind of outlined here, right? We want to get the two equations in similar forms and line up the variables. If necessary, we're going to have to transform some of the equations by multiplication so that we can do elimination. By adding similar terms, we're going to be able to eliminate one, we're going to solve what's left over, and then plug that back in to get our other variable, and then we can check our answer if we want to, as always. Okay, so first example here. So that first step was get everything lined up and in the same form. So you can see how we have our, oops, that's not the color I wanted. We have our x variables here, right? And then we have our y variables here. We then have our constants in the same spot over here. And also very important, our equal signs are both, I meant that to be a different color, are both right here, right? So they're lined up. We've got everything vertically lined up in the two different equations. Okay, so then once that is done, we need one of the variables to have the same number, but one positive, one negative. So if you look at our y variables right now, that's a positive or a negative 1y, and that's a positive 1y, right? So they both have ones, but one's negative, one's positive. Okay, so now once we have that situation, I can actually just draw a line underneath our equations, and we're going to add the two equations together vertically, right? So 5x plus 3x, that gives us 8x. But then when I do negative 1y plus positive 1y, I would end up with 0y, right? And then 12 plus 4 gives us 16. So that 0y means that's just 0. So if I get rid of that, then all I have left is 8x equals 16. And then if we divide both sides by 8, then we get to say that x equals 2. Right? So now we've just solved for one of our variables. So now that I know that x equals 2, all I have to do is take that x and plug it back in to either one of my two original equations. It does not matter which one. So I'm going to take the top equation and say 5 times x minus y equals 12, and just plug in 2 for x, because that's what I just found, is that x equals 2. So 5 times 2 minus y equals 12. That would be 10 minus y. And then if I subtract 10 over, I would get negative y equals 2. So that means that y would equal negative 2, right? Get the opposite. So now we've got our x and our y value that go together. So the solution to this system would be 2, negative 2. Right? And that means, remember, that I could take 2 and plug it in for the x, negative 2 for y, and both of those equations, and it would work for both. That's the point where the two systems, or where the two equations intersect. Right? Okay, so that's kind of the first few steps of elimination and how that works. Let's add on another step this time. Okay, so this time, again, all of our variables are lined up, right? The 6 C's, the D's, and then the numbers and our equal signs in the middle. So everything is good and set up. Come on, pen. There it goes. Okay. So then I want to look at, do I have one variable that has the same number but opposites? Well, if I look at my C's, they both have 6's. The problem is they're both positive. So when I go to add those, I would get 12C. That doesn't eliminate the variable, right? I want to add those and end up with 0C. So instead, I need one of these to be negative, one of those 6's. So I'm going to take one of the equations and multiply it by -1. Okay, so then if I do that, I then end up with -6C minus 7D equals a positive 15. If I distribute that -1 to all of those terms inside there, right? And then our bottom equation would stay the same. This is doing a transformation, right? Put that one step up above it by doing a transformation. Well, now I have a -6C and a positive 6C. So when I go to add them together, the 6C's, that's just a 0C. That's our eliminated variable. And then -7D and -2D would make -9D. And 15 plus 12 will give us 27. Divide both sides by -9. We get D equals -3. Right? And so now that we have what D is equal to, we plug that into either equation and we can get C. So I'm going to take the second equation this time, just because I feel like doing something different. And I'm going to plug in D, which is -3. And now I can solve for C. So 6C, and -2 times the -3 would make a positive 6. Subtract 6 on each side. So 6C equals 6. Divide by 6. So then our C equals 1. Now, it's kind of different here because we have a C and a D instead of X and Y. If it's ever a different variable than X and Y, just put them in alphabetical order. So my ordered pair would be 1, 3. That's the solution to that system, the point where those two lines intersect. Okay, so we had to do a little bit extra step there. The first one, we could just go ahead and add the two equations together. There they go. Okay, they just add together. And then the second one, we had to multiply one of the equations so that we'd have opposites. Right, so that time we got opposites. Okay, let's take a look at another one here. Okay, so our next, on this one, notice they're all lined up, right? X's, Y's, and numbers. But this time we have a 4 and a 3 and a 5 and a 10. So we don't have two of the same number. So this time I've got to somehow get one of the variables to have the exact same number. This one, I would probably look at this 5 and 10 because I can multiply 5 by 2. And if I do that, it becomes a 10, right? If I wanted to use the X's, I'd have to change both of those numbers because I can't do 3 times something and get 4 or 4 times something and get 3. So if I pick the 5 and 10, then all I have to do is take this top equation and I need to multiply it by 2, right? So if we do that, then we'll get 8x minus 10y equals 46. And then my bottom equation can stay the same, 3x plus 10y equals 31. And now notice in the middle here, we have a negative 10y and a positive 10y. So one's negative, one's positive, and then the same number. When I add those together, they're going to cancel out and go away, right? So we add them together now. 8x plus 3x is 11x. So that's gone, it's eliminated. And then 46 plus 31 is 77. Divide both sides by 11, and x equals 7. Once we have our x, we're going to take that guy and plug it back into either equation to solve for y. I'm going to go with the first one, a little bit smaller numbers. So 4 times our x is 7 minus y equals 23. Oops, 23, not 25. That's 28. I'm going to subtract the 28 over so I can solve for y. We get negative 5y equals -5. Divide by -5. So y equals 1. All right, so then we've got our ordered pair, right? So our solution to that system is 7, 1. Remember, x, y. That's the point where those two lines intersect. Okay, so that time we didn't have two of the same number. We had to multiply one equation by a number to get the same coefficient so that those would eliminate. All right, we've got one or two more here, I think, right? Computer's starting to be slow. All right, our last two here. Yep, okay, couple more. All right, our next one, again, same idea, lined up, right? But notice this time we've got a 3 and a 5 and a 4 and a 9. None of those, I can't multiply 3 by something to make 5. I can't do 9 times something to make 4. So this time, we're going to have to multiply both equations by something. Now, you can choose to do whichever variable you want to. You could do the 3 and the 5, or you could do the 4 and the 9. So you could eliminate A's, or you could eliminate B's. Most people tend to try the first variable first, just because that's what they like to do. But I'm going to go with that because it makes a smaller number if I do 3 times 5. Okay, so I basically need to make this one and this one have the same coefficient. Kind of like getting the common denominator, if you want to think about it that way. So I'm going to take the top equation, I'm going to multiply it by 5, and the bottom equation I'm going to multiply by 3. That way, when I do 5 times 3, I get 15, and down here I do 3 times 5, I also get 15. So then I've got the same number on each term, right? Oops. The only problem is I want to make sure I also have one of those be a negative. They need to be opposite so that when I add them together, I end up with 0. So it doesn't matter which one. I need to choose one of them to be negative. I'm going to go with the top one, because why not, right? Okay, so then I'm going to distribute in my -5. So that would make a -15a minus 20b, and then equals -5 times 2 is -10. By the way, that last number is the one everybody always forgets. I tend to get people distribute it to these two and then forget that other number. So make sure you do all 3 distributions when you're doing this. Okay, and then on the bottom, I'm going to multiply everything by 3. So I get positive 15a plus 27b equals 3. Okay, now we're ready to add those two together because we've got a -15a and a positive 15a. So when I add those together, that eliminates. And then -20b plus positive 27b would give us a 7b. And -10 and 3 would leave us with -7. Divide both sides by 7. Oops. And we get b equals -1. Once we've got b, we'll log it back in to find a, just like we've done before. I'm going to use the top equation. So 3 times a plus 4 times -1 equals 2. That's 3a minus 4. I'm going to add 4 on each side. And then divide, oops, get ahead of myself, divide by 3 on both sides. So a equals 2. All right, so then I've got a and b. We'll write those together as an ordered pair. Again, just use alphabetical order if it's not x and y. So my answer would be 2, -1. That's the point where those two lines intersect. Okay, so that one, we had to do a couple things. We had to get it to be the same exact number, and we needed one to be negative and one to be positive. If you get to this step after you've multiplied things and you don't have one that's positive and one that's negative, then you weren't ready to add them together yet, right? It has to be one positive, one negative, otherwise it doesn't work. Okay, take a look here. The last couple. We have one or two more here. Let's see. 2 more. Okay. Okay, so next quick example here. Now this one, we've got a fraction involved. Don't let that scare you off. Don't change it to decimals. We have dealt with fractions so many times this semester, and remember one of the easiest ways to handle it is get rid of the fraction if you don't want to have to deal with it. So before I even think about doing anything else here, I'm just going to multiply this guy by 3, and then I can get rid of the fraction, right? So then that would make 5x plus 3y equals 7, and then 4x plus y equals 14. right? Now, if you're okay with handling a fraction and making a common denominator and doing the fraction math, you can just eliminate the y's here instead and multiply one by a negative. You're just going to have to do like a 5/3 and a 4 and do that math. If you don't want to deal with the fraction, change them and get rid of it first. Okay, so now that I'm looking at that system, it looks to me now you could do x's or y's. I think the y's would be easier because I can just multiply the bottom equation by a -3, and that way I'd end up with a -3y on the bottom. Okay, so then when I multiply, I'm going to keep the top equation the same. 5x plus 3y equals 7. And then the bottom equation, I'm going to multiply by -3. So that would make -12x and minus 3y equals 14 times 3 would be -42. So then 5x minus 12x gives us a -7. My y's are gone. And then, come on, pen. -42 and 7 would leave us with -35. Divide by -7. And we get x equals 5. Ta-da! Right, and then again, if you don't want to mess with the fraction, plug it into the one where there isn't a fraction. Then you don't have to deal with it. We get 4x, oops, but x is 5, right? Plus y equals 14. So 20 plus y. We're going to subtract 20 on each side. We get y equals -6. So our ordered pair there is 5. Come on. 5, -6. Okay. Kind of getting the hang of it, hopefully, if you've seen or watched this many examples. There's just lots of little different things that happen, so I wanted you to see lots of different examples. Okay, our next one here. Now this one, to do elimination, and actually if I was using any method here, this one is very nicely set up for substitution because you already have a y equals, right? Substitution was where I wanted one of my equations to look like that to start with. So if this was a choose any method question, I'd probably choose to do substitution there. But since instead it says to solve by elimination, this one we've got to get the terms in the right place because here I have a yx, an xy, I have one equal sign here and one equal sign here. They're not lined up, right? I need to rearrange these. So I'm going to move this 3x, I need to move it over to the other side. So that way they're in the same place. So then this first one would become -3x plus y equals -7. Right? All I did was take that 3x and move it to the other side. And then my second one is 6x minus 2y equals 12. So that way I have the x's, y's, and numbers lined up and the equal signs are in the same place. To finish this one, let's see, we've got y's in the middle there, a 1y and a -2y. So if I multiply this top one by 2, then I would end up with a 2y in the middle, right? Okay, so then we're going to get -6x plus 2y equals -7. And the bottom, I'll keep 6x minus 2y equals 12. Okay, now when we go to add to these, look what happens. My x's, they eliminate. My y's, they eliminate. So everything ended up being 0x and 0y. So that would just leave us with 0 on the left side. And then -7 and 12, that makes 5. Okay, now this should look familiar. 0 does not equal 5, right? That is a false statement. It doesn't work. So if 0 doesn't equal 5, then that means that there's nothing that will make this system work. Right? The answer here is just no solution. So if both of your variables are eliminated and you end up with a false statement, then that's a no solution problem. Okay, the last one, I think it is. Okay, so one last little note on this guy. If by chance you were to do this problem and like end up with something where you got 0 equals 0, remember that is a true statement, right? So if you end up with that, it doesn't mean no solution. That would mean your infinite solutions. that means basically you've got the same line and all of the points intersect. So that's where we wrote our solution as xy, and then we kind of wrote the line there, right? So if you end up where it's not true, it's no solution. If you end up where it's true, it would be infinite solutions. Okay. All right, so lots of different examples there with how to go through elimination. Again, today you're going to do your homework on Delta Math. So going through those problems, make sure you're using a separate sheet of paper so you can do the work on your paper and understand how to work through the problems, right? If you're just cheating yourself out of doing the work, you're not learning anything. You won't be prepared for next year and for SATs and all that stuff. So let me know if you have questions. That was kind of a long note, but homework should be okay. So let me know if you have trouble.